This episode of Serverless Chats is sponsored by Amazon Web Services. This week, I chat with Xavier Lefevre about your typical serverless architecture. This is Serverless Chats, episode number 70. Hi everyone, I'm Jeremy Daly and this is Serverless Chats. Today I am chatting with Xavier Lefevre, who I'm going to have repronounce his name afterwards. Hey Xavier, thanks for joining me.
Thank you for having me. So my name is Xavier Lefevre in French, which is not easy to say.
So you are the VP of Engineering at Theodo. So I'd love it if you could tell the listeners a little bit about your background and what you do at Theodo.
Yeah, so I'm going to start by Theodo. Theodo is a product consulting and development agency. So we worked with clients of any sizes, with companies of any sizes to build websites and complete web applications for them for different kind of use cases. So it can be a big company, it can be a small company, it can be e-commerce, it can be a big industry, anything. We are in France, UK, and USA, London and New York to be exact. And we're doing several different types of verticals. So we do mobile, we do infrastructure, and that's something that could be interesting, like Kubernetes a lot, and stuff like that. So that's Theodo. And for me, so I'm a VP engineering of Theodo in France at Paris. And I have a funny background. So I went to business school when I was younger, and I did a business school, but I always wanted to work in tech. And when I got out, I started to work in tech, but as a business role. I really discovered what it meant to work in tech and the different roles. And I finally realized that I prefer to be a tech myself. So that's why I'm here today.
Awesome. So you are a bit infamous now. You have this article that you wrote called The Typical Serverless Architecture, which got a lot of praise and also got a lot of criticism from people who don't quite understand serverless architecture. So I would love it just to kind of go through, and we'll start with this. There's other things I want to get to, but let's start with that. Let's start with this typical serverless architecture. Take us back. What does that look like?
So from experience, and I have a year of experience in serverless, so I'm still compared to you, I'm still young. But from experience, I started to, of course, dig into serverless, understand a little bit everything that's included in the technology, and I wanted to show this big picture and this big idea of what a typical architecture is. So what can you find inside? You can find, so we go through each blocks, okay? I can talk about the origin as well, which can be interesting. Which one do you prefer first?
Well, so I have them listed here. So let's start with the front end. What does the front end look like in a serverless application?
So let's do that. So front end itself, well, your front end is going to be a SPA, for instance, like React. It can be Next, for instance, with SSR. What you can find in there are two things that are specific to serverless. The first is AWS Amplify, which does a lot of stuff, but among which you can find UI components in there that help you go faster, and you can find SDKs that help you communicate more easily and find pre-made features with AWS services like Cognito, for instance. You can authorize your user and handle your users directly from your front end thanks to AWS Amplify. So that's one piece you can find. The other one is if I go a little bit further, when you host your front end. So you have two steps. First, the basic one, if it's a SPA like React, you just have to host static files with your JS that's going to be loaded on your browser, and that's going to run. We know how it works. So there you're going to use S3. It's going to be exposed by your CloudFront, and that's it. If you want to go further, which happens a lot lately, even more because it's powerful, if you want to do SSR or SSG or a bit of both, and you can do with Next, for instance, here you can take advantage of Lambda at edge, which are Lambdas directly inside of CloudFront that run close to the users that are super fast, and that can take care of generating your pages for you in terms for performance purposes or SEO purposes. So that's one capacity in terms of front-end in Serverless.
All right, so now you've got your front end and you've got it hosted either in CloudFront or maybe even Amplify Console, which is different than Amplify. You can host SSGs there as well and things like that. So what about for domains and certificates? How do you manage your domain names and your certificates in a typical serverless architecture?
Here you're going to have two services that are quite famous as well in AWS. You're going to have certificate managers that's going to help you deal with your certificate and HTTPS. And you're going to have Route 53 that's going to help you deal with the domains. They plug directly, easily with the rest of your serverless architecture, and you don't have much else to do. And we're talking something interesting as well in the middle. We're talking about a lot about AWS because indeed those services and from experience, we found the serverless experience more, let's say, more finite and more complete in AWS. But of course, you can do those kind of stuff on in other cloud providers.
Yeah. All right. So then, so now we've got all this stuff set up. This is our front end. Now we actually want to be able to process APIs. So how do we build out our business APIs?
Okay. So there you have two choices first about the route you want to expose through your API. You have API gateway, even more complicated. You have two API gateways, the V1 and V2, which are not named V1 and V2. Not easy. And you have AppSync on the other side. Okay. So API gateway is about making REST APIs. AppSync is about making GraphQL APIs, mainly, if I have to just recap really fast. Of course, they have a lot of capacities inside. One API gateway has an option to use API gateway WebSocket, for instance, to do real time. AppSync has embedded GraphQL subscriptions with pros and cons. So you have those two. Depending on what you want to do, REST or GraphQL, okay, that's your gateways. Then behind that, you're gonna have your business intelligence. So you can directly connect those gateways to lambdas at first, mainly, to code your site. So lambdas, what are they? They are functions, just little functions of code that you split, that are super macro that you split. You give them, you push them and deploy them to AWS, and they do the rest. They handle the scalability, the uptime of those functions. You don't have to take care of that. So you connect your gateway to lambdas. From there, what we do, and it's not something new, and it's not something specific in serverless, and you could do it differently. We organize our lambdas in services. Okay, we do follow the idea and the principle of microservices. Behind that, the idea is mainly it's mainly a developer pattern to have a well-organized architecture and to have an architecture that's going to last long in terms of complexity of thinking. So we follow domain-driven design at max to have clear separation of concerns between those microservices.
Right.
And
right. So then you have all these microservices that are separated. Now, one thing about microservices in general, and certainly with serverless, is it is a distributed system, right? You're communicating with lots of different moving parts. So you're not going to connect every piece of business logic or everything that you do. That's not all going to happen synchronously, right? So we want to send an update to Marketo or to Salesforce or to something like that. We're going to do that asynchronously, right? So now you've got these Lambda functions that get processed from your business APIs. Then how do we connect all these other services that you have and do that asynchronously? Okay, so indeed, there are several ways of doing that. So there is this idea of serverless being event-driven by design. That's something that gets mentioned a lot, and you can see it in most services. Lambdas react, and most services here react on events. So API gateway connected to Lambda is an event, but you can also connect it to other services like SQS, like EventBridge. We do use EventBridge for us to split and communicate between our services in a let's say uncoupled way. EventBridge is an event bus, is a serverless event bus. It's like a RabbitMQ, but in easier. So which is extremely comfortable, and it's scaled by design.
So one microservice is going to handle, let's say, is going to be the article microservice. Okay, it's going to communicate with the user authentication microservice connected to Cognito, for instance, which is a AWS service meant for authentication and users, and they're going to communicate through this event bus. So the article, for instance, is going to push the fact that there is a new article, and is not going to know to the whole, let's say the whole architecture, and is not going to know who is going to consume that. And Event Bridge is then going to make sure that this message is relayed to the services that want to consume this information and react on it. If you want to go further, DynamoDB has a service inside of the service, which is complicated, called DynamoDB streams. You can use the fact that you're going to push changes to the data inside of DynamoDB to trigger other events, uncoupled, so event-driven events, to make side effects. Like, for instance, triggering another Lambda. It could be something like that, and doing something like, so this data changed in my database. I want to send an email, but I can decouple and ask for DynamoDB stream to trigger this effect. The advantage is that the first Lambda that changed the data synchronously ended earlier, and to the front end showed to the user that the request was accepted.
Okay. And so then now you have these back-end processes that are running these tasks, right? They're asynchronous, so the user's already connected. They can take longer to run if they need to. They can fail. They can retry. Got all kinds of things like that. What if after one of these processes finishes, you want to push data back to the user somehow? Is that you do that with WebSockets and AppSync, right?
Yeah, that's exactly what I would do. I kind of took a look at the options you could have if you want to push data, if you want to do real time. So if you want to, like, in a simpler way, push data from the back to the front end. The best options are API Gateway WebSocket or AppSync subscriptions. So API Gateway WebSocket, from what I understood, and I think it didn't change yet, you have to ping the API per connection to ask to push a message to the front end. The difference with AppSync, where you can send a batch of messages in one go. So that's one difference and one pros of AppSync you can find. But in both scenarios, that they're amazing services, really reliable, and that's how you push your messages to the front end with those two services.
Right. So then in a serverless architecture, we have no servers, right? Or at least no servers that we know of. So if you want to upload a file, which is a common thing that people would want to do, maybe upload a profile picture or something like that into an application, how do you do that in a serverless application?
So we use the infamous S3, which is a file storage system. So one thing you can once again, in this event-driven manner, is that you can generate file URLs, file upload URLs with S3. So you're going to ask your backend to generate with a token and highly securized upload URLs that you're going to send back to your front end. The front end is going to directly push the file to S3. And then in this event-driven manner, S3 is going to, if you want it, is going to be able to push an event to trigger another side effect. The fact that this file has been uploaded, you want potentially to mark something somewhere in your database. So you're going to do it this way, completely decoupled.
Okay. All right. So now users and authentication. You mentioned Cognito. What else do we do in order to authorize users into our system?
So Cognito is the go-to authentication and user management service in AWS. So that's where you're going to have your user base. That's where you're going to have your user access, and you're going to be able to connect it with other services to make those authorizations. So, for instance, in API Gateway, for each Lambda, you can say that you can attach an authorizer, which is directly connected to Cognito, and say that this route is not going to be accessible to this type of person. That's how you're going to do it.
All right. And so now let's say you have a complex workflow in a serverless application. You mentioned Lambda functions. Each one maybe does a discrete piece of business logic, but let's say you got to connect 5 or 6 of them together or more because you're doing some sort of checkout process and you need that workflow to finish. State machines, how do we build those in serverless applications?
Yes, so this topic is interesting because it's something that gets after some point workflows gets complicated in most architectures. So you could do it, of course, you could do it yourself with your own lambdas, but it's in the end it's going to be complicated. It's going to be tricky to understand where the data is going and stuff like that. So AWS has another service for this, which are called step functions. Here you describe your flow at the configuration. Okay, so you're gonna describe your steps. You're gonna describe your states, and how the state is supposed to change step after step. You're gonna say that it needs to wait, it needs to come back, it needs to be handling error, and you're gonna do that with step functions. The nice thing with it is that AWS takes care of this flow for you, autoscales once again this flow for you, and makes it as well super visible. So you have a nice user interface to understand what's happening, where are you when you're debugging and when you're developing, where are you in your flow, what data went where, and what are the logs out of the box. So that's really super comfortable to handle complex workflows after some point.
Right. All right. 2 more to go. Security.
So security. The two things I put forward inside of this article is one is called IAM, which is extremely famous. It's identity and access management. It's where you're gonna define, configure all your authorizations inside of AWS. So this user has access to this service. He has access to this exact action inside of this service. But it's also where you're gonna say that you're gonna define the security of the accesses between services. So this Lambda can have access to DynamoDB and stuff like that. Out of the box, the idea with IAM and a good practice is to you're gonna help me in finding this term again, is to use the fact that no one has access to nothing, and then bit by bit you open those accesses.
Yeah.
What's the name of it?
Principal of least privilege, right? Yeah, right. Block everybody by default, and then the principal of least privilege open up just what that individual function or user needs.
Exactly. So with IAM, you do that out of the box, which is a pretty good security principle. So that's one service. Another service I put forward is how to take care of secrets and your API keys, for instance. So there are several services. There are 2 services for that. One is called Systems Manager, and the other one is called Secrets Manager. In my opinion, there are some differences, but you can do both for handling your secrets and your API keys, and not having to version them somewhere else.
Right. And then the last one, and this is important, monitoring. How do we monitor a typical serverless application?
So this one is extremely important. We are in a distributed system, indeed. We are in an asynchronous system. So understanding what's happening, what event did trigger what action is indeed complicated. So out of the box, CloudWatch is a de facto solution. It's connected to all AWS services, at least all the ones we mentioned before. And that's where you're going to have all your monitoring. You're going to find all your logs. You're going to be able to customize the logs and the metrics you want to push there. You're going to be able to define, not easily, that's still an issue, but it's powerful. You're going to be able to define your dashboard, your alarms, and you can do a lot of stuff, in my opinion, with CloudWatch. It's in my opinion, it's almost self-sufficient. But one thing you need as well in terms of observability is to understand what's happening in your whole system, and CloudWatch is not enough for that. CloudWatch is going to be micro. It's going to be able to show you some very specific pieces. But if you want to understand, so this user made this action and triggered this whole flow, and I want to understand why it created this error at the end and come back to the flow. For this service, there is one called X-Ray, which is doing tracing end-to-end between your services. That's supposed to be the go-to. But the problem is that for the moment, and you can correct me by saying for the moment it's the case, X-Ray is not supported by all services. And even Bridge, which is at the heart of our microservice architecture, is not supported by X-Ray, which is a little issue.
Correct. All right. So you just listed, or we just went through 11 different sort of categories within a typical serverless architecture. And we probably mentioned 20 services, and there's even a few in there we probably didn't mention. So the criticism I think that you got from this article that you wrote, and it's probably valid criticism, nothing on you. The article was great, and I think this is exactly what a typical serverless architecture looks like. But the criticism was, wow, this looks really complex, right? You've got a lot of different things. So what do you say about that complexity, and also who does that complexity now fall on, right? Because this sounds like the developers in this case are going to be doing a lot of these things that maybe were sort of the ops jobs in the past.
That's the key question and the key topic when I released this article, and to the person that kind of criticizes architecture, this article, I think I'm going to show them the video of what's his name already, the one that sings with the piano with all the services of AWS.
Yeah, Forrest Brazil. Yep.
That video is amazing. Yep. If I send them this video, I think they're going to tell me, you see, we were right. And yeah, maybe that's true. Yes, there is a crazy amount of services, but it's just that, let's say, the way of thinking, the mindset needs to shift. The complexity and the pieces you find in an architecture at the same, let's say, level of application, it's the same. We're not inventing something. It's the same. We're just reorganizing a little bit the way you connect those pieces. So of course the critics were around, but I don't understand why there is so many pieces. You take a monolith, a framework monolith, you connect it to a database, and it does everything you mentioned there for you, and there is no issue. And that's true. The thing is that behind this monolith, you will have the potential scalability problem with it afterwards. You will have it at some point, and you will have to have your company is going to grow, and you will have to split it in services, and you will have to be able to make them scale, and you're gonna bit by bit explode this architecture. And here, serverless is asking you to think about that ahead of time, right from the start, but it's also helping you to do that properly and to not have to think about scalability anymore later, not at all. So yes, indeed, as well, it changes a little bit the weight on the developers. The developers have to think from the get-go about this organization and how to split it and how to communicate between those different services. But once again, it's something eventually, and we're talking about applications that are gonna need a little bit of scalability, or that are gonna have some up and down traffic that will need eventually those kind of stuff. And we're getting it from the get-go, which is super comfortable. And from experience, it's positive.
Yeah, right. And you mentioned a good point about, eventually companies are going to have to split up monoliths. And I know that there are a lot of companies that run on these big monoliths, but if you've ever worked on one, when there's a new piece of functionality that needs to be added, it's always like, what am I going to break if I put in some new service? And I've always told people, 10 years ago, I would say to people, when you're building a new application, you just want to get it out there, right? Like, don't worry about scalability, right? I mean, if you get 1,000 users and your servers are overwhelmed, then great, right? Then you now have something, and maybe you can start re-architecting and getting it where it needs to be. But you don't want to spend all that time building in that scalability on a typical server app or server-based application right from the get-go. You want to get the project out there. But that changes dramatically with serverless, because you can build these things very easily. You can get them out there very quickly. And if you just think about a few things with the scalability aspect of it, in terms of what you need to do to make sure that your functions are split independently and some of these other things, you can scale right up, and you don't have to rewrite anything.
Yeah, I completely agree about that. And there is a good practice when you develop, you have your development flow. A good practice is always to cut down your features in very small pieces. It's always a good practice to be able to have a good mind control on what you're doing, and to make sure that you're not gonna generate a bug, because it's easier to think through. No? So this human thing of splitting things in small pieces to make sense out of them goes goes as well inside of the fact of building an architecture. So indeed, in the time, I don't know, 5 or even 5 serverless started to become popular 5 years ago, something like that.
Yeah, about 5. It's been 5 years or so. Yeah.
Yeah. So a little bit before that, if you wanted to be able to do those microservices, it was a little bit more complicated because of the infrastructure you had to put around it. Because of all the complexity and all the tools you had to put, and you had to manage yourself to make them work. Now, the super nice part is that AWS took care of this complexity for you, and you can split this complexity in several pieces to make sense out of it from the get-go. And just this simple idea is extremely powerful, and you can see it in a lot of other fields.
Right. Yeah. And I think that, some of these individual services that are available to us help just by their sheer, I guess, design or the way that they're sort of meant to be used, already have the thought of scalability built in, like DynamoDB, for example, right? Like thinking through those access patterns, like your database is going to scale, for quite some time. Like you don't have to worry about it, and you build something in MySQL or something like that, and that's going to work great until you maybe have 100,000 records that need to do some sort of cross join or something like that with these complex filters on them, and then all of a sudden that's going to slow down.
Yeah, that's true. We did. I think I forgot about DynamoDB in the business part break of my typical architecture. But yeah, DynamoDB is the serverless database recommended as well from the beginning. And indeed, it's amazing to see as well this shift in paradigm and the fact that you change. It's always around. It's mainly around performance and the fact of making sure that the system you're building is performing and long-lasting at the same time. And DynamoDB is a very great example about that, because when you did SQL, you thought about a clear and easy to think relational model. Okay, so it was normalized, everything made sense, all those models had a meaning and a clear entity, and you saw the direct connections between them. But the issue is that it was growing. And at some point, so your SQL queries got bigger and heavier. And there you had to do some tweaks. And here you had some performance issues and complex performance issues usually. At the same, so you had to think about reshaping your data or improving your SQL performance, request performances. Or other things, you had to think about scaling your database. But scaling the SQL database is much more complicated because it's a huge blob of data. And you don't exactly know when and how you're going to access those data because it's inside of your SQL queries. So, So doing a horizontal scaling of that is almost impossible because you're going to get some data here, some data here, some data here in this horizontal scale, and it's going to be terrible in terms of performance. So DynamoDB shifts that, and think about how you're going to access this data, think about performance, and think about how you're going to store this data from the beginning, from the moment you put this data inside of the database, and there it works. After it works, I'm not saying it's easy. Entering inside of the DynamoDB world is funny. You have to, once again, it's a change of mindset, but it's an exciting one as well. I really enjoy to think about access patterns and how to store data inside of DynamoDB. But then it works. After that, it works. So there is also always this critics about, but do we need that? Do we need this change and this let's say extract complexity from the beginning? But the idea is that it's, of course, you have to learn something new, but it's not the slope is not that big, and the reward after is amazing. It's just amazing. You don't have to think about those stuff later. And I hope your business is going to be powerful, and I hope your application is going to have a lot of users, and you're not going to need to think about that.
Right. Yeah. No. And I love DynamoDB, and the advice I give too is if you're thinking about massive scale, DynamoDB, you're not going to get the performance out of a SQL database no matter how much, with MySQL or Postgres, whatever you do. But with DynamoDB too, if you're using if you have a small set of data, but you need to kind of query it a couple different ways, throw a couple of extra GSIs on there. It's so easy to do that. But anyways, so I'm going to put the link for this article in the show notes because I do want people to go and check this out. But it is very complex, and it has to be, right? As things get more advanced, they get more complex. So how can people start building this out? You're working on a boilerplate for this, right? That can just kind of help people, maybe.
So yeah, exactly. So in our company, we do develop and we do greenfield projects a lot, and so we have to have something that's strong and that's easy to use and that has all the quality tools and good practice and best patterns from the get-go as well. So yeah, we are building a boilerplate for this purpose, and it's like how to handle well a mono repository of serverless microservices, stuff like that. A lot of little stuff that have a lot of value, and you're really happy they're there because it takes some time to set them up. And so we're doing that, and we're thinking about sharing it with the community. So it's gonna come super well along with this article. And then we have some specific services that we want to prepackage as examples, and for us that are useful, and so we think it can be useful to others. Like for instance, this file upload. Uploading files like that, it's not that complicated, but no, there is some specificities here regarding security. Not being able to push a file anywhere on S3, or being able to just put an index.html at the beginning to just as a hacker to just make some fun. That's some stuff that could happen if you don't know about some good security practices. So we want to push some blocks of this architecture as examples inside of along this boilerplate. The WebSocket one, for instance, as well. It's something we are thinking about.
Awesome. Well, that will be a huge help for the community and people building it. So I am looking forward to that being available. Hi everyone, I want to take a moment to thank our sponsor Amazon Web Services and tell you about the recently launched AWS Serverless for Startups portal. If you are an aspiring entrepreneur, a technical founder, or anything in between, you have to check out this newly launched Serverless Hub. You can get access to AWS credits plus a ton of technical resources so that you can build, iterate, and scale your startup idea faster and with less overhead. In my personal opinion, if you're building a startup today and you're not seriously looking at a serverless first architecture, you could be putting yourself at a competitive disadvantage. Learn how to empower your startup with AWS serverless architecture at serverlesschats.com/AWS startups. All right, so I want to move on to costs. Because that's another thing. You look at this typical serverless architecture, you've got a lot of individual Lambda functions running. You've got a CloudFront out front that obviously the data, the fees from the data get kind of expensive there. You got DynamoDB, which can get expensive if you have a lot of transactions and a lot of things happening there. So you do have serverless costs, or serverless still costs you money. But the question is, or I guess the question that gets asked quite a bit, and most of it is anecdotal, is this idea of, is serverless cheaper? And you have a serverless calculator that you put together, and I want to get to that, but let's talk about what we have to think about. What are the costs involved when we're building a cloud application? Because it's not just about the hosting cost.
No, it's not. That's when you intuitively, when you don't know about serverless, that's what you're gonna think. You're gonna think about your EC2 bill, and then you're gonna compare it with the corresponding bill in AWS with all the services you have in a serverless project. But it wouldn't be fair to compare them in this way. We didn't talk about cost at the beginning of this whole podcast because we knew we would arrive there, but that's also one of the big advantages of using the technology. So we talked about all the services. We talked about services that are auto-scalable. We talked about services that already have pre-made, let's say, packaged features like Cognito. And if you take a step back, that's where you think, and you can use the idea of TCO, total cost of ownership, which encompasses infrastructure costs, development costs, and maintenance costs. And that's where you can really see the value of serverless. So we talked about the infrastructure cost. Indeed, that's your bill. You can compare. That's the EC2 bill you have. That's the cost of your infrastructure. And then maintenance costs. So it's going to be the time you spend to patch your systems or to make sure that in the middle of the night, to fix something in the middle of the night. And the last one, the development cost, is the time you're going to spend to indeed plug an open source authentication brick inside of your architecture and to make sure that it's working well with the rest of an architecture that was not out of the box made to go with it. And the idea with serverless and all the services we went through together is that they all work on those three aspects of TCO. So when you look at the serverless bill at the end and all the services, you have to look through and think that they help you on the TCO itself. But then my question was, and it's the same for the first article about the typical architecture. When I entered this world, it was complicated. It's a new world. It's still a new world, even though it's 5 years. And to understand what's in a serverless architecture, and then is it really cheaper? How do I make sure that how do I understand that it's really cheaper? There are some examples. There are some calculators. There are some articles talking about TCO, some great ones. There are some studies or use cases, but still, I was missing something. So I wanted to work on that. That's why I worked on the calculator.
Right. So I want to get to the calculator in a second, but I do want to clarify a couple of things too, because I think what you see typically when companies try to build out their own component, right? So they want to build their own, security or authentication component. Part of the problem with building any system that is your own, something that is not unique to your company, and as we always say, undifferentiated heavy lifting, right? It doesn't add business value to you for you to own your own authentication system. The problem with building something like that on your own is not only the development time that it takes. If I can turn on Cognito or even Auth0 or something like that, and I can immediately have secure logins and password reset flows and multi-factor authentication, all that stuff's built into me or in for me, and it might take me, I don't know, maybe half a day to read the documentation and set that up. Maybe it takes a day, but it might take me weeks and weeks and weeks of development time to build that myself. Sure. Then here's the problem. Let's say the person who built that, the lead architect, that person leaves and he or she goes to some other company, and now your other devs have to be the ones to maintain a system that they don't necessarily understand fully, which means what always happens when they do that? Someone wants to rewrite it, make changes or whatever, and then you've got more development time, more maintenance costs, things like that. Whereas if you hire somebody who knows how to use Cognito or knows how to use Auth0, then that's just done for you. Yeah, you have to learn how it integrates into your system, but most of that is becoming very standard. So that's the thing that I think a lot of people don't necessarily factor in as well, is that that ongoing maintenance cost, it's also about having the people available that know that to maintain it. Because you can spend a lot of time having somebody relearn something, trying to figure out what some developer did, 3 years ago and is now unreachable.
Yeah, I couldn't say it better.
All right, so we talked about TCO, which is great. So let's get into this. Cost calculator, into the serverless cost calculator. So you built this calculator. It's in Google Sheets right now, right? So you can just make a copy of it, right? And you can do some of that stuff. I know you said maybe you'll do it as a web app or something like that, but I think Google Sheets actually is really nice because you can go in as an easy interface. So tell us about this. Tell us about this serverless calculator. What's different between like the AWS calculator that that AWS has on their website?
So the AWS calculator itself is extremely powerful, but you have all the services. It's the 250 services. I don't know how many you can find in the video we were mentioning. So it's crazy. You don't know what to look at. And the thing I wanted is my focus is to evangelize a little bit about the added value of serverless for people to really help people. That's what I think, simply. And I wanted to create something that could help people that don't have a crazy expertise in serverless to be able to assess the potential cost of a serverless project for their use case. So I needed to think about, and the AWS cost calculator is like that. It's complicated. It's deep. It's micro. So I wanted to build something like that. So I thought, what can I do for that? Well, what's going to make the difference? There's a lot of parameters. There's a lot of variables. But which one do I set? Which one do I fix? And then I don't think about them anymore. And that's why as well I thought about writing. It was just the first step. I thought about writing this. What is a typical serverless architecture? Because I wanted to set a fixed picture and starting to set some variables for the potential calculator coming behind. And which services, how do they communicate with each other? What do we use in them, and stuff like that. So build this image of what a typical architecture, a serverless architecture is, and then I went further and I made the calculator. So the calculator, it has a tab. It's a spreadsheet. It's easier indeed to play around with it. It's easier indeed to. The idea as well with the spreadsheet is to be transparent. So it's easier to be transparent with the spreadsheet. Everybody can see everything, the calculation and the hypothesis we made. So you're going to find there, you're going to land on it and you're going to see the main dashboard. That's why you're going to see the price output. You have some basic variables on the left. You still need some because you need to add them to your use case, of course. And then the price output on the right, and below you're going to have the detail per services. And then you have several tabs that correspond to each of the AWS services we were mentioning before. And so the detailed calculation based on AWS costs, calculus costs, and the variables that are necessary for each of them. So we use the color code to show that there is some that really are set because it doesn't have a big impact on the cost, or because there is no reason to really tweak it. It's okay like that. Your architecture is going to be fine like that. And then there are some with a different color code, some that are going to be pulled back at the central dashboard to be able to play with them and see the impact it has on the cost. So you can use the calculator in two ways. You don't know, you just want to play around. You have a broad idea of a website, of a type of website, an e-commerce, a blog, a tool, a work tool, and with a certain amount of traffic. So just that. So you have some drop downs, you can change them and play around and directly see the impact it has on the cost on the right per month. And if you want to go further, from there you have the capacity of changing some user variables. I call them like that because I think that you don't know about serverless architecture, so you're not going to know how many lambdas you're going to trigger. You're not going to know how long they're going to be triggered. So I needed to pre-sync and prepare those variables with an extra layer. So here, you're going to be able to play with user variables like the number of sessions per day of those users, the percentage of users that are authenticated. So this is going to have an impact on Cognito, for instance. The average size of the uploaded files of those users, stuff like that, which are more product oriented. So I don't know. I'm a CTO, and it's been a long time. I didn't code. It happens. And I want to be able to assess the value of this technology for my company. I hope that's my idea, that's my objective, to help him being able to do that.
Yeah, no, I mean, it's amazing. And I love the calculator because it basically says, all right, here's that typical serverless architecture. Here are the individual components that are running. And then not only that, but like trying to estimate, well, how many, DynamoDB requests are you going to make? Or how many Lambda functions? Or, what does it cost for the events? All these kind of things. If you just look at 30 services or whatever it is, it just gets really, really hard to estimate that. And so, like you said, if you're a CTO or you're just somebody who's evaluating serverless, going in, not only can you use it to actually give you some good numbers, but it's a really good learning tool to go dig in and say, oh, okay, all right, so these would be the components that would be running. If I change this, I see how that affects, the cost. I love the fact that, you can bump up the number of Lambda invocations like dramatically and like the cost changes by like $3.
And you can see the impact on the rest of the system. That's something I like as well.
Right.
Because those lambdas are going to use Eventbrite, they're going to use DynamoDB, they're going to use a lot of other services, and just dump your number of lambdas for services that are having extra costs, but which is still cheap. Absolutely. We're going to talk about that after.
No, but it is. It's really great, and those different sort of predefined scenarios are also really helpful as well. Because even if it doesn't, meet your use case exactly, it's going to be pretty close. So let's do this, because you give a couple of examples in an article. You wrote a blog post about the calculator itself, which was a very helpful blog post as well. So let's go through some of these scenarios in terms of low, medium, and high traffic, because this is one of those things where you did did a comparison for just the cost, not including engineering time, not including maintenance costs. This was just straight compute or infrastructure costs. So let's start with the low traffic one. So this was about 50 sessions a day. If it was an e-commerce site, what would this cost you in a typical serverless application?
So I wanted to start low, indeed. So I wanted to compare easy accessible values. So indeed, the cost of the EC2, of the simplest EC2 you can find, there's the architecture we mentioned earlier. So if you do 50 sessions per day of an e-commerce app, you're going to pay $1.6 per month. So including the free tier, but the free tier that's always free. So it's going to be like that for everybody. And if you do a blog, for instance, so a little bit different in terms of user variables, it's going to be a lot more read, of course. It's going to be $0.5. Okay, so now I thought, in front of that, what if you don't do serverless, what are you going to do? It's something super simple, but you need to have some compute. You don't have the choice. So AWS for that has EC2, an EC2 VM, the simplest one, the T3A.nano. And how much is the T3A.nano? It's 3.43. So that just this little picture is amazing in my opinion. You can compare it's 2 times more expensive than the e-commerce example we mentioned, and it comes naked. You don't have anything in this VM. You have to put your framework. You can put your database in there if you want, but I don't think it's such a good idea. So let's say that you're going to use a RDS to have a SQL database a little bit managed. So you need to add the cost of RDS, which I didn't even include there. So So it's
that's what I was going to say is that what I thought was sort of funny about like this example for $3.43, that is just running a that T3A Nano for 720 hours a month or whatever it is, but you have no redundancy. So likely what you need to do is you need to add a load balancer, which I think costs like $25 a month, and have at least 2 of these things running so that they're there. You also said, again, RDS, like you would want to put RDS in there somewhere. Even if you choose the cheapest RDS, just one server, I still think that costs you maybe $15, $16 a month, something like that. So already you're exploding those costs. Now, again, that's pennies, right? We're not talking about a lot of money there. But what about if we move on to something a little bit bigger, something like a medium traffic? Where would we, so 2,000 sessions per day?
So 2,000 sessions per day, same type of applications, e-commerce app, serverless one, $70 per month, okay? And the blog is going to be $20. Okay, of course, e-commerce is a little bit more intensive. Then I continued the same kind of comparison at this layer. It was if I'm capable of showing that EC2 is more expensive than serverless, I don't have to go further and to dig into the TCO topic because you don't even have to. And there I asked from experience, and I asked to colleagues, and I took a M6G.large. It's one VM, which is corresponding to this size, let's say, of application and traffic. This VM is $62 per month. So I said the e-commerce serverless app was $70 per month. The blog was $20. So we're reaching, the VM is slightly lower in cost compared to the serverless e-commerce app. But it's super close. And once again, I thought it was enough because once again, the VM comes with nothing. You still have to put your events, as you said, you still have to put your RDS and stuff like that. So no questions asked, honestly.
All right, so let's move up to the big one. This is the high traffic, 40,000 sessions a day to maybe up to 1 million sessions a day.
Yeah, so there I reached a certain limit. High traffic and very high traffic, that's how I call it. And there, indeed, it's more complicated to compare. Those systems are much more complex. There is much more blocks in if I had to compare serverless projects, like the one we showed with the same in Kubernetes with all the crazy amount of pieces you can find there, it's a good work. So that's something maybe I'm going to do one day. But here I didn't have this information yet. So here I took the cost, of course, of the serverless e-commerce cost based on the calculator. It still works, and it's 1.7K. It's $1,700 per month for high traffic. Okay, and a blog is going to be $475. Okay, so we're talking about 40,000 sessions per day, which is starting to be nice per day, starting to be a good thing. And then if we go super far and we think about a million sessions per day, when you're there, you're pretty successful normally. Normally your website is pretty successful. I don't know if I put a website that's close to this. An example of no, I didn't. You have an example of a good website that has 1 million sessions per day? I don't know. It could be nice to be able to compare.
Yeah, it would be good to compare that. But so back to the 40,000 sessions per day, 1.7 or 1,700 USD per month for that. And then you had, for a very high though, if you did 1 million sessions per day, you had $49,000.
Okay, yeah.
Is that right?
Yeah, so it's $49,000. So you're giving AWS $50K per month. So it's starting to be a lot. It's a lot. But at the same time, your company in front of that is big. You have 1 million sessions per day. So you do have something that generates when you're e-commerce. So you sell products, or you're a blog, so you have advertisements. So you need to reassess how those 50K enters inside of the business model, of course. And I don't think for this size of just out like that, without even entering in the TCO IG, it can be acceptable. But then to be able to really, so I did not have to compare this with EC2. There is no way of comparing this with EC2. So I didn't put a comparison in front. Here, I needed to take a step back to think about this idea of TCO, total cost of ownership. So I dug inside of studies, of articles. I read a lot about that, and a lot of those articles say that the amount of energy you put on non specialized ops tasks is going to lower. It's going to lower by. It depends on the articles, but it will really have an impact, and you will be able to have less amount of time spent on that. There are I have a lot of examples of companies that do serverless that don't have ops. They don't have ops at all. They don't.
Right.
But it doesn't mean that they don't need ops. It just means that they infuse it inside of the rest of the tech people. But let's say, for the sake of the exercise, that you're not serverless. You have 2 ops. Okay. You have 2 ops inside of your team, and you pass serverless. So you reduce by 2. Let's say you reduce by 2 this size of team because half of those tasks are not necessary anymore. If you take, it's just the example. It's an example in Paris. If you take the salary for the company, of course, it costs more for a company than what you see at the end on your payroll of an engineer. It's 140K per year. Okay, so with serverless, you're going to go down to 1 ops. So it means that you're going to save 12K per month. Okay. So this team of 2 ops, it was for high traffic websites, for the one that had what was 40K sessions per day. So we were talking about a AWS bill of $1,700 per month. So it means that you saved 12K per month, and you pay $1.7K per month to AWS. So there is a save of 10K in the middle of that somehow. Right. So if you think about TCO, of course it's always more complex than that. But the idea is here. If you think about TCO, even if you when you go further and you go to extreme traffics, it can have value. Once again, of course, we're not talking about Facebook or Twitter. That's an extreme, and if you reach this, it's amazing. You don't even have to read this article if you reach this anyhow. That's for sure. And there, of course, for a lot of reasons, you're going to have your own team to do that, and it's going to be huge. It's going to be amazing. But for the mortal people, for us, for the ones that are interested in this article, it's showing that indeed serverless can be cheaper and can be amazing for their use case. That's what I wanted to share.
Yeah, no, and I think you're right. And then there was you referenced this paper on TCO by Deloitte. I'll put the link in the show notes for this. But I think that that's a really interesting point, right? Just the idea of reducing the number of things you have to do that are just pure maintenance. Again, it adds no value to your company to have somebody installing patches on a server somewhere or worrying or being on call. Now, again, you get to Facebook level, or maybe you get to a point where you're at that million sessions per day. Maybe it ends up being cheaper just to have ops people that are constantly watching containers and a Kubernetes cluster and things like that. But until you get to that point, you can save yourself a lot of money by reducing the number of people that you need working on the ops side of things. And I want to say this because this is something I know that a lot of people maybe worry about, is to say, well, what happens to the ops jobs? Like, so we just said we get rid of one of the ops people. And that may be true. Maybe it's better to say we just won't hire more ops people. But what would you do with what would you do as an ops person in an architecture like this, right? Because there's still more things that can be done.
There is still a lot of things that can be done. Of course, you have the change of observability that gets bigger, that gets created. You have a lot of different moving pieces, and you need to understand what's happening there. So there is some more work to put inside of observability, which is a pretty good field to dig into. And for me, it's also it's a DevOps task. And then you have a lot of security concerns, and there's always going to be some security concerns. And you have as well, you can spend some more time to think and talk and think and improve your security, which is good for everybody, because there is always leaks. Every week we have the news of a new leak, and so you spend some more time on those kind of tasks.
Right. And CI/CD, right? Just getting things into production.
I didn't even, indeed. Oh, that's amazing. Thank you for that. I forgot about this one, which is a big one. And yeah, CI/CD is still super important, and you want your developers to be as fast as possible, and to have as less issues as possible during the development and testing and validation phase. Serverless gives you the opportunity, like really, really easily, to spot feature environments. You just with your CD, you're capable of with a simple configuration to create feature environments on the go like that for testing the development for a new development in an isolated manner. And this, it's amazing. Honestly, before serverless, I worked on projects where we had that, but it was a hassle, and it was big projects. We had to reach a certain level to be able to do that, or to want to spend energy in building that. And with serverless, directly you're capable of doing that, and that's amazing. So indeed, your ops team is going to be able to do those fancy stuff that you dreamed of even more easily.
Right. All right. So if you're an ops person, don't worry. Just evolve, and you can work on things that are much more exciting than just patching servers and worrying about your VPC configurations. All right. So finally, so next steps on the calculator, right? So this is you'd mentioned that it's sort of just a start, that you've got some other things you want to do with it. So where is this going to go?
So I'm going to continue using it. I'm pushing it internally, but I want to go further. So I want to be able to challenge it based on some real use cases. So I have had the input, and I'm working with some fellow community members, which is super nice, to be able to do that. I'm going to challenge the data we have to make our hypothesis better. And then, which is one first step, then we can add some other services like AppSync, for instance, because AppSync is pretty popular, it's getting more popular, and I didn't put it inside of the calculator. So give a little bit more options, to the table. I need to find the right balance, because the idea of an opinion is to have an opinion. The opinion has value in itself. So if it's there is too much option, I'm going to come back to the AWS calculator, and that's it. So I need to find the right balance, but some options is good. And then, depending on that, next step could be potentially to build an open source website for it.
Awesome.
I think it could be fancy.
So listen, Xavier, thank you for your opinions, because your opinions on this have been great. Excellent tool. The article was great. I think there's a lot of learning just to kind of put it all out there, and having your experience and sharing that with people is amazing. So I know I appreciate it. I'm sure the community appreciates it. And again, thank you for being on the show and sharing all this knowledge here. If listeners want to find out more about you, how do they do that?
So Twitter, of course, first. You're gonna give it after, I guess. It's
I will put it in the show notes. Yeah.
Yeah, you're gonna give it. But I'm gonna say it out loud. It's at Xavier. It's too complicated. _ Lefevre. XAVI _ LEFEVRE. Okay.
Right.
So on Twitter.
You spelled your name right. Awesome.
on Twitter, on LinkedIn, of course, on Medium, and I'm planning on releasing articles, but even more than that, I'm planning on updating my articles. I want those articles to stay up to date. I want this typical architecture to still be actual in 6 months. So I'm gonna work on, and I have some ideas already. I'm gonna work some on update of my articles, so you can follow it along on Medium.
Awesome. Well, I will put the links that we mentioned in the show notes, as well as all of your contact information and the serverless cost calculator. Thanks again, Xavier. It was awesome.
Thank you very much for inviting me. That's me that thanks you.
And that's this week's Serverless Chat. I want to give a huge thank you to Xavier Lefevre for being my guest this week, and to our sponsor, Amazon Web Services. If you want to check out the show notes and a full transcript of this episode, you can find them at serverlesschats.com/70. For more serverless chats, subscribe, sign up to be an insider, check us out on YouTube, and follow us on Twitter, Facebook, and Instagram. You can connect with me on Twitter at Jeremy_daily. And if you want to keep up to date on everything serverless, make sure you subscribe to the Off by None newsletter at offbynone.io. Thank you so much for joining me, and I look forward to chatting with all of you again next week.